So one of the more complex questions you hear in commercial roofing is whether or not hail damaged your single-ply membrane. Especially when it comes to EPDM, this gets complex. Now with TPO and PVC, you do have a scrim inside, so it's more often that you actually see fractures in the membrane or fractures in the scrim. Sometime when the damage is kind of just barely enough to damage it, you can actually cut out a piece of the membrane and either put it under a microscope with a lit plate underneath, or you can shine it up to the sun and you'll see fractures of the scrim inside, period. But what becomes difficult, especially with EPDM, is when there are no fractures defined. A lot of contractors make the argument that it damages the underlying substrate, typically being insulation plates. And so this is a actually really complicated question. It seems like it would be simple: if there's a dent, it's damaged. And that's kind of the argument you typically hear contractors make. So there's two major theories behind this. And so the first theory is that if it's a fully adhered roof, it breaks the bond between the membrane and the insulation. And the second theory is that it damages the insulation by impacting it, and that by impacting it, it reduces the effective R value of the membrane, which is the same as increasing the U value of the system. And so something needs to be said about this. So the first one I'm going to go over, and I'm going to go over the impacts to wind uplift resistance on a fully adhered system. So there have been a lot of tests on this done over the years. And when it comes down to does this have a significant impact, they've tested everything from wood fiber to using like EPS and XPS systems with low-rise foam adhesives, polyiso, gypsum board, and concrete board. And pretty much everyone's agreed it doesn't have any impact on gypsum, doesn't impact on concrete, doesn't impact wood fiber. Pretty much the argument has been with everyone that the most substantial impact would be to polyiso. And that's because of the thickness of polyiso and how it will compress it and break the face on it. And so one of the largest, most significant studies done on this was done by Donaldson and Savage. And so they kind of did an assessment here, and it's called the Hail Impact Effects on the Wind Uplift Resistance of Fully Adhered Single-Ply Roof Membranes. I know, incredibly long name. And this was a test that was designed to fail. Not only were they simulating impacts on the face of the ISO, not just impacting it, in some cases they were actually removing the facer intentionally where the impacts were, giving it the weakest possible bond imaginable. They tested 1-inch size, 2-inch size, 3-inch size hail. They tested systems where 5% of the board was completely and intentionally debonded. And so these tests, sometimes which include, hundreds of little impacts, were tested, and what they discovered is that when they tested these systems, they took the baseline test, which failed at around 142.5. In some cases a little higher, in some cases a little lower, but that was their baseline, was 142.5 PSF. And as they tested this, they tested it with different diameters, they tested it with, more and more volume of impacts. And this test was designed to fail. They intentionally made sure that the membrane wasn't bonded. They didn't test what it would look like if the membrane was bonded and then that impact happened, because we don't even know if it actually separates the bond in those areas for sure, or if it just breaks the face. But they did make sure those areas weren't bonded. And what they discovered first is that the first thing that's going to fail is your adhesive to your insulation plates. Regardless of the hail damage, even if it's a 3-inch diameter void, it's going to fail at your insulation plates first. And even in their strongest of tests, their strongest one was actually 135. But they had some tests that actually exceeded, where after it was debonded, the membrane performed better in some cases, reaching up to 165 PSF, whereas again the baseline never exceeded 142.5. And so this is actually pretty fascinating because it indicates that those small little pock marks, as we often call them, could actually potentially improve the system. But overall, if you were to look at, hey, if we had a 5% margin of error, almost everything fell within that with the exception of a couple tests. And what they discovered is that even at the most severe cases of the 3-inch hail, or where they had, literally hundreds of impacts, there was no significant difference. And in many cases, the system was exactly the same or better in some cases. And this was with, again, 142.5 PSF. So this is simulated at a much higher wind, a much higher negative pressure, a much higher height of the building itself for this simulation than you would almost see in anywhere in America. I can't remember the exact number, but if I remember correctly, they stated that this test was chosen because it would simulate, worse than more than like 95% of buildings in America. So there's pretty much nowhere where this should be exceeded that isn't some special zone where you probably couldn't even do just a straight adhered roof anyway. And they found no significant difference whatsoever. Once you hit about 120 PSF, the problem becomes the bond to the plate in a lot of cases. But at the end of the day, even the membrane starts to fail at that point. There was nowhere where they were able to find anything that in any way really indicated that there was a loss in value from hail. Now that turns us over to our second point. And so this I'm going to call the Danielson theory or Brockman theory, because they both kind of brought this up early on about how could the effects of hail reduce insulation value. And so Hag Engineering, Hag's very famous for being an engineering company that works mostly for insurance companies. It's had its good and its bad, but they do produce a lot of theories out there. And so Stephen Smith, Robert Danielson, and I can't remember the other one. I think it was, I don't know how to pronounce the other one's name. I know it was Corey, but I think his name is Hurtubise. Got together and they performed a study called The Effects of Hail-Caused Dents on the Thermal Performance of Insulation Under Single-Ply Roofing. And this was produced about a year ago, or actually 2 years ago now. It was in 2022. And so this was probably the largest to-date test as far as analyzing what hail did. And they tested it against polyiso, XPS, EPS, and perlite, because there's nobody out there that's claiming that your gypsum or concrete are going to see any significant difference. And what they discovered is, in some of these tests where they ran literally hundreds or more impacts on an area, I apologize, I'll start over. What they discovered is, on these tests where they were literally running hundreds of impacts simulated in an area, you would see R value difference, of course. And so when they tested individual pieces, now I really want to make this very specific. They tested individual pieces of insulation, not total systems. So when they tested EPS, they tested it at 1-inch thickness and 2-inch thickness under multiple tests, and they discovered that with EPS, there was actually a slight raise in the R value. I know that seems strange, but they found that when testing the EPS after impact, there was as much as a 0.0000337 R value change. So to actually break it down, EPS actually improved as it became compressed. When doing it to polyiso, the loss was greatest on 3-inch thick polyiso, and they found a 0.0000857 change. And so you break that down, that's, you're not even talking about a 1% or a 0.1%. You break that down, you're talking less than a 0.001% shift for the most part in these insulation values. And so that was with 100 indentations. So after the simulation, they tried to, how many how many indentations from a typical hailstorm would it take in order to cause a decrease of 0.5 R value. And so it would take 2,786 impacts per square. 2-inch size impacts. Now, not 2-inch size hail, 2-inch size impacts. Bear in mind that your impact is going to be smaller than the actual hail itself. So 2,786 impacts in a square in order to have a 0.5 value difference. Now, there's a couple things to point out about this study, just like the other one. It is designed to fail. And so the first interesting point is that is 0.5 even significant at that point? It's really not. Especially at the end of the day, it's considered an insignificant amount. Even the study concludes that the R value of a roof insulated by polyiso to the point that any meaningful compliance issues could occur. It just takes way too much hail. But the other side of that to consider is that we're looking at the R value of that individual piece and not at the entire system. What most people don't understand is that any kind of void, even a void, in air, a gap between two pieces of insulation, does provide on some level some insulating value. And they did not assess for that. They assessed what was this individual piece. So there's actually a chance that any air void that would be left between the membrane and the insulation could actually account for additional R value. It could actually improve the total system value, theoretically, especially when you look at the size of the impact versus how little it impacted the R value. The R value of air is not 0, that's for sure. It's closer to 1 per inch. And so take that into account, combine it with how little of an impact it makes. Then combine it with, that's the impact it made on 3-inch polyiso. If you drop it down to a thinner polyiso, such as using 1 inch, 1 inch on the other hand had a 0.0000691 R value change. And so it's actually about 0.0000, I apologize for that, 1/6 less. Now, the majority of systems nowadays, you don't want to use just a 3-inch ISO. Especially if you live in the colder areas and you need 4 inches of polyiso, it's very rare you actually use the 4-inch thick polyiso. You usually use 2 layers of 2. If you need 5 inches, you use 2 layers of 2.5 or 2.6 and 2.4. And a lot of times what you do is you put the thinner one on top. Say you needed to use 2-inch and 3-inch, you'd put the 3-inch on bottom and then the 2-inch on top because that's going to be the smoother application. And so the argument that R value changes based off of just a mild amount of impacts from hail was deemed to be insignificant. Now, with XPS and Perlite, there was no measurable difference. And bear in mind, this is a system that is measuring down to pretty much the millionth decimal point when it comes to R value. So for them to say it's insignificant, I mean, that we're even talking about a 0.0000857 change is astronomical in my opinion. Like, there were previous studies on this subject in the past that dismissed it completely because their equipment only measured down to the 100,000ths of an R value. That we had to go to this extreme says a lot. And again, we're not talking about percentage of change. We're talking about, that's how much of an R value. So you're talking about 0.0000857% of an R value. Well, remove two zeros actually. Sorry about that. So it's actually as 0.00857% of an R value change. And bear in mind that we're talking about a material that, depending on what brand, depending on what year we're even talking, probably had a 5.6 per inch R value or above, sometimes up to a 6. So you're talking about a completely insignificant argument that, again, quite literally the air pocket left behind might literally be more R value than what was theoretically lost. And so there's really no argument to be made about this. Again, with EPS, it was improvement. With XPS, there was no difference. With Perlite, there was no difference. Previous studies have shown wood fiber, gypsum, concrete, no difference. The only system that ever showed any difference, negative impact I should say, is polyiso, and it was so insignificant that it took one of the largest engineering firms in the United States to even have equipment strong enough to measure that minor difference. Now, if you want to talk about that minor of a difference, here's something fun. The amount of R value lost from installing a single plate for a mechanically fastened insulation board is greater than 100 impacts. I'm not even kidding. If you actually look at the R value lost when you're fastening down polyiso, how much is lost on average per plate is actually greater than 100 impacts in 3-inch polyiso. You would actually gain more than that if you did, say, a fully adhered system where you adhere the insulation down using low-rise foam adhesive. The amount of R value you would gain from that is generally considered to be less than 1 and not worth measuring, but would still be greater than the R value supposedly, theoretically, lost from hail impacts. And that's before you start getting into the air pocket argument. Especially if you've got insulation that's 2 layers of insulation that's staggered, that loss is never going to make a difference. So I know there's an argument out there a lot of contractors make that if the insulation shows any dents, it has an impact, but there is just no significant evidence of that. And the more we study it, the more we start to find that there's absolutely no justification for this argument anymore. It was one thing when we didn't have the science, now we have the science and we're still making the argument.